That's right. That's right. So let me tell you basically who I am. I'm Dennis Mancl. I'm retired from Bell Labs. We did turn on the recording. We're recording. Okay. So yeah, and legacy software is something that I've stubbed my toes on in the 1980s, right? Oh, we can't change this. We need this system because it's running our manufacturing processes in Allentown, Pennsylvania, or Oklahoma City, or wherever we had a factory, right? There are systems that are collecting quality data or running certain kinds of processes or so on, and we need them. So I talk about old software that hasn't been forgotten. It hasn't been forgotten because we need it, right? This is an essential part of our business. So what can I tell you? When we talk about legacy system, it's always a trip to the past, right? So in this talk, we're going to talk about legacy software and software engineering practices that I think are actually pretty important in developing good software. And remember, software development is the nuts and bolts on how we actually get software, launched and people actually using it. And software engineering is the topic of developing applications at a reasonable cost with good quality, just like any other kind of engineering endeavor. Well, guess what? Software engineering is very good engineering. That's all right. We won't pay attention to that. Okay? And in fact, this is all very practical, right? A legacy system is old software that's still in use, still delivering value to users. In theory, we could rewrite it. In practice, what happens is any attempt to rewrite this would probably miss something, and would probably miss something really, really important. So if we could go back, in our time machine and get the original developers and talk to them and say, hey, tell us what you were thinking when you were doing this. Well, we actually have the traces of what they had. It's the code that they run, right? And if we have the change management system, we say, oh, and we can see all of the false trails and all of that sort of thing, and that might even actually be useful. But yes, it does seem like it's getting more and more expensive to keep old systems working, right? Especially if it's written in something like a legacy language. You remember Y2K?
Oh yeah.
Do you remember the consulting rates that COBOL programmers were getting?
Oh yeah.
Because, everybody says, well, we were going to go over to PeopleSoft, or we were going to go over to, whatever some of the new business frameworks were that would actually have a Y2K stuff. But we're not going to make it in time. Let's get some COBOL programmers and let's fix up our code back. So it's difficult for newly hired developers who work with an old design. It's bugs. Customers want a more modern interface, right? But the value of the code is that the people who wrote it understood the domains better than we do, right? And that is something that's like the fundamental rule of legacy software, right? Oh, these people were stupid, right? Look at how terrible their code was. Oh, these people were brilliant. They were doing all of this stuff with stone knives. They talked to each other. They worked with the engineers who were actually using this in the field. Okay, so yes, the replacement system, in order to get it to implement some of the complex logic, some of the business rules that are actually there, would be a real problem. So we need to make calm and rational decisions about how we replace the software that we have. All right. So thinking about software. I used to work on telecom software. Actually, I consulted with people who worked on telecom software, but I actually wrote some myself. It's fun, right? Every product release is an adventure, right? There's a bunch of old features that you better make sure that they still work. I mean, our saying in Lucent, at least, was if Verizon isn't happy, we're in trouble. right? So whenever Verizon says, oh yeah, all those old features, yeah, if one of them breaks, yeah, stop what you're doing. Don't go to the movies. You know, we're going to be in for the long haul. Okay, but they're asking for new features because hey, we've got these markets. We want video over our networks and all of this sort of thing. So how do we do this? Right? Yeah, the managers are always saying the new stuff is great, but don't screw up. Cool. So wait a minute, software doesn't wear out. Bit rot? Well, really, we have bugs, errors, and defects in code that they're in there, and we just haven't found them yet, right? You were talking about it in the last talk, that you make some little typo. Making a typo is not immediately fatal. It may just not execute that code, or it may actually produce a value, or it may reach out on something that's on the stack and it's been already erased. Oh, but it's still there, right? Until you take a different call flow, and then it's kind of like that gets overwritten by 3 times 10 to the 15th, and when it used to be 0, and it's like okay. So adding a new feature is like looking at the requirements and forwarding to new devices is probably the most important thing to have. Oh, I've got this wonderful wireless system, right? But I have new base stations, right? I have new, network gear in the backlog. And it's like, oh, how can I adapt this so that people still make calls the way that they did the old way? And maybe a few of the new features, but, oh, we've upgraded from this version of VX groups to that version of VX groups, right? Oh, my favorite. We compiled all of this stuff on Sun computers using the Sun SparkWorks. But now we've converted everything over to Linux. So guess what we're compiling? We're compiling with GCC. And if you think the Sun C compiler and the GCC C compiler are the same,
I bet you if they did data, they would.
yeah. Well, and so one of the rules that we kind of used in code reviews for a while was, has the system been compiled with 2 different compilers, right? If it compiles successfully and seems to work pretty well with 2 compilers, the chances of a third one if working is actually pretty high, right? But and if you're using, oh, this program is correct, it works in this system. Well, it's using some dark corner of the language, right, in this code. And it, happens to compile a little differently on this other compiler. If that happens, and you're in that dark, you don't want to be in that dark corner, right? You want to clean up that code and you want to make it as vanilla. So this is the slide that talks about the things that I learned actually when I was in graduate school in the late 1970s, right? Because about 1980, right? Nathan Swanson actually wrote this wonderful book on software maintenance management, and they had this very clear perception that there are 3 kinds of changes to make the system. And as I got out into the telecom world, it's like, this is right? There's bugs, right? Corrective changes have to be made to the software all the time. Oh, we shipped this, but it's really not right. Stop the presses. Let's go in and do this in, right? There's perfective, right? Which is we need and this is working, but it should work better. And the third kind is adaptive, and that's something in the world changed, right? And you're racing to catch up, right? Oh, your system has to interface with some hardware. Or you have a whole new generation of TikTok users, right? And all of a sudden you say, oh, yeah, I have to adapt to that. Okay. So a system, software system is always changing unless it's dead and bare. And we kind of like not don't want to be in that situation, but it happens. Okay. So this gets to actually the fundamental thing I wanted to talk about in this talk. And you know, it's the fundamental thing because I have a star on this. Right. And this is an idea that I heard about back in like about 1999 from some of my Bell Labs friends, especially the ones in Illinois who were working on central office switches, number 5 ESS, Autoplex, various things. And the idea is something called discovery costs. Some people would call this learning curve. But discovery costs, when you pick up a piece of a small software system. My favorite example is I have a friend she's a professor at University of California, and she's fortunate, right? And she's quite brilliant. And she talks about in her lectures, runs a course on different programming styles. And she has a book, and it's basically all about different programming styles. She writes the same program 31 times in this book, right? All of them in Python. But like one of some of them are like, just simple, top down, you do this in Fortran, right? Or, oh no, this is a functional program. Oh no, this is an object-oriented program. Oh, this is an agent-based, and there are agents that are doing different parts of the algorithm. And what the program is it's something really silly, right? It reads 5. And it counts the number of occurrences of each word frequency in the file. It takes a Jane Austen problem, scan it in, and say, there's lots of disregards. Elizabeth. It's like, okay. And then there's a little list of words that you don't count, like and, be, and say, okay, this is we don't want these. So what you do is you count up all the words, and then you sort the list, and you say, I want the top 25 words that Jane Austen. I want top 25 words the New York Times, or TikTok. Yeah, okay. So it's a nice little piece of software. You can go on to her website and you can download, the whole directory, right? And it's each one is a standalone application. There's a README file, right? This is how you use it. Okay. How do I build the software? Well, it's Python. You don't have to build anything, right? It's execute, right? Just the right command line, comes in from a file. Okay. What environment do I need? Well, I better have compliant Python system, right? What do I need to read first if I want to make changes or adjustments? Well, you might want to get the book, that talks about the different philosophies of this code thing, right? How do I test that everything works as advertised? Well, guess what? We'll put in a little test program to say, oh yeah, here's the output you should get for these. So fairly straightforward. All right, so now we're talking about 5 ESS, big electronic switching system. It's a just the generic, just like 6 million lines of code. And then it's mostly in C and some special scripting languages. How do I build it? I had friends in the Oklahoma City factory where they were making the 5 ESS hardware, and they were the system tester. And they said, we have 3 machines that are constantly building the software because each build is specific for a particular city, a particular customer, right? And they said we have to compile from C, we have to link in all of the different libraries, and it takes 2 days to build an image, right? Back into these really fast machines, so we do a lot better today. But the build process is very complicated, and was a lot of it automated? Sure, right? But okay, suppose you go to you go online and you look for some open source packages, right? I don't know if you've had any experience with this, but they say, oh yeah, Here's the build script for this. Oh, and by the way, check to make sure that you have these versions of these other OS packages on this system. So building software and configuring it to actually make sure that it'll work in the environment that, on your PC or in your lab, or if you're an instructor, it'll work for all of your students, right? This is hard, right? Reconfiguring the system in a different environment or a different time zone, or some of my students in France, and some of my students were in China, and it's like, okay, can we do some localization? Sure, I have a different network. The testing process is quite elaborate, and some of it's manual, and some of it's automated. Okay, so if you find yourself on a project where you're just working with these little single bits, it takes you 10 minutes to figure out how to configure it, great. Unfortunately, most of the services situation, we have a lot to learn. And the discovery costs, as I say here on the bottom of the slide, they're the things that you need to learn in order to do the job you need to do. And that job might be just to grab something off the internet and compile it and then install it for classroom people. Or that job might be making the next version, right? In order to handle some of the customer requests or the management requests that we talked about on the previous slide. So this is okay. Oh. So we wrote a nice paper that was in Bell Labs Tech talk about some of the experiences of AT&T and Lucent in this world of making all of the legacy stuff back and dealing with discovery. And one of the things is, if you're hiring new employees, you know that they're only going to be about 20 to 25% effective, because they're spending a lot of their time learning and asking questions of really busy people who are getting things done. It's the Brooks Law thing, right? They don't know your build process. They don't know the unit test framework. They don't know the range of customer configurations. They don't know all of the things that happen. First year is cool. Then the dinosaurs came. But they died and turned to oil, whatever the history is, right? And they don't know how this actually happened. So how effective is a new employee on day one? Absolutely useless, actually, right? Because they come in, whatever experience they come in, which sometimes that learning curve, they'll raise questions.
Right,
Say,
right.
hey,
They're going to ask questions like,
Yeah.
why are you doing this?
yeah, new stats,
It's like,
stats.
because we always did it that way.
That's right. That's right.
What documentation do you have? Is it any good? Is it accurate?
Oh yeah.
And oftentimes there's none.
Actually wound up working with it. This was in Columbus, and they were having huge problems in trying to integrate this. And one of the problems was they were working on a new platform that was a multi-processor Unix. Okay, and the problem was kind of event processing, right? This program actually, and a lot of telecom systems have this, is they have a heartbeat. They're basically set a timer that every second it will go off, right? You'll get a signal handler in Unix, right? Will actually go off and handle this, and it's got a list of 4 or 5 things that it has to do. Second, well, what happened was the timer signal was disappearing, right? It would work for a while, and after a couple hours, they said, it forgot, because it's like, okay, after re-enable signals, something went wrong. Okay, so they said, can you help us track this problem down? I said, okay, and I'm looking through all of the signal handling, and I'm nodding my head, and I'm reading the comments, and it's like, and I said, wait a minute, I'm not making any progress. Let me try something really strange. And I wrote a little script that stripped out all the comments. And I'm only looking at like about 200 300 lines of code. But pretty good code. And without the comments, it took me about 15 minutes. And I said, oh my God. If you're in the middle of this and another signal comes in, it'll never come back. And one of the comments confused me, right? And once the comment was gone, it's like, oh yeah, the comment wrong.
Yeah.
Was it accurate or just?
No, the comment
The
was
comment
wrong.
was just completely wrong.
It was completely wrong. The person who wrote the code actually wrote decent code, but it was wrong. And the comment that they did actually covered over.
It might have been right initially.
Yeah.
The code got changed.
Oh, yeah. Oh, yeah. Yeah. And I think the multiprocessor actually kind of, screwed it up too. So, okay. So new employees are one challenge. But a second challenge is moving people around, right? You've been moved on to a different project, or you've been moved into a different job role. You used to be in development, and now you're in system test. Or you used to be in system test, and now you're in integration, right? And now, what are the discovery costs there? Well, you're in a different job role, or you're on a different project. You don't know the project's build process. They don't know how the project does that testing. They don't know much about that project's customer. They don't know the project's long history. I mean, does this sound familiar? Okay. So how effective is a transfer employee on day one? Not as bad as it is. But as you can see, you actually start adding costs as you move people around. Having investment in knowledge and experience is actually a good thing for and I wish the Agile folks stuff's upstairs, right? And I love Agile, right? The rule of thumb from the Bell Lab studies, it takes 3 release cycles to get up to speed, where you still have some discovery costs because of the way that the release cycle. But to get your discovery costs down below 40% or 20% of the cost, it's like it's a struggle, right? Even after you've done it once, it's still like around 50 discovery. So learning. Yeah. So that's the main thing I want to talk about. Learning activities. What can you do to mitigate discovery issues? Code review. Make sure the developers have the time and the tools to actually piece through some of the code and understand, right? To explore. Not just, hey, we've just hired somebody with big drum. So you're just going to keep developing this fast. No. Having code reviews and internal talk. Code reviews are one of the great ways to share information, right? Everybody say, oh, you're finding bugs. I don't care if I find bugs. What I hope to come out with is that the next time that person sees that code or is working on something in their interfaces with that code, they say, oh yeah, internal chalk talks are just like, it's not just entertainment, it's sharing information and sharing techniques, adding missing documentation, reverse engineering the missing design documents for your legacy code. And I think this can be important to get off the internet, get open source, it's like, this is a physical documented, but we can create our own design document, got the source code, right? Having simple models is probably more important. And I see people way over. They say, I have this 9-page UML document with all of the classes, and all of the methods, no, you don't want that. What you want is a skeleton. This is the architecture. This is how actually push together. I use informal brainstorming methods like CRC cards to say, hey, let's write down the main responsibilities of each subsystem or each module, and we don't have to get into all of these details. It's just everybody knows. If you use more formal methods, keep it simple. And then experiment. Software is an experimental science. Believe it. Say, I wonder what would happen if this. Ooh. Oops. Whoops. But that's okay. We put it back. So investing in code reading because you don't have time to understand and discover the code. You wind up doing the worst kind of software. It's called clone and modify, right? Or copy and paste. Oh, I need to do something that's just like this. Let me copy that code over here, and then I'll dress it up so that it actually does what I wanted, right? It's the worst kind of reuse because the code is more complex, more brittle over time. And this is one of the ways that happens. Suppose that original code seemed to work fine, but it actually had a subtle problem that would manifest itself in scenarios we just haven't gotten to. Okay. Like for instance, it's gonna trip on that because of some of the state things, right? So, but some other folks in the project have said, well, we don't really understand this that well, but we've copied it over and dressed it up with this. So there's 6 different copies, right? And yeah, that means that your test track down 6 times as many defects. Right? Because then they're going to fix it in one place and then say, oh, where did this come from? All right. So poor code structure. I mean, these are all the kinds of places you can run off the rails. And it's not just the 2 character here, but the 32 time values. And we had a chance with 64-bit and Unix to basically say time t is 64 bits. No, it's 32 because of compatibility with so we still have the Y 2038 problem, which most of us may still be around. That's okay. I'll have my money on 8-bit characters. The Java folks are happy. They say, "Oh, that." Right. And more languages want that way, which is poor algorithms, poor practices, and fixing bugs. What I really want to mention here is, and I've done another talk. I did a talk for our Princeton ACM IEEE chapter a year ago on refactoring. And refactoring is a way to make incremental improvements to a legacy database. You try to improve the code structure, but don't change its functionality, right? And the idea is that you're preparing the way for being able to add new stuff, but you're cleaning things, you're cleaning up the code as you're going. Now, refactoring is something people actually do for decades. But the first refactoring tool started in about 1990, and I got, my friend Bill Updike and Ralph Johnson at University of Illinois did a paper on this back in September 1990. Bill Updike, who's one of my co-authors on the paper, on discovery. He's a big expert. He's like about 6 months younger than me. So refactoring has to be focused. You have to be humble. You can't say, oh, I'm just going to refactor everything because I don't like the way that this stuff is formatted. You have to say, oh, what parts of the code base are changing the fastest? Where are we actually adding? Let's focus on those and make those better. Or, we find some mistakes. We find about, oh, that's an opportunity to go in and refactor. We're looking to cut down on duplicated code, but don't go crazy. All right. Make the campsite cleaner for the next set of campers. Now, in my refactoring talk, I actually go into this, the code smells thing, because in the agile, between very, very short iterations, and you don't know where the next changes are going to come. So you can't use that heuristic of, work on the most places. So what you do is, get this out of the way. Yeah, there we go. Yeah, instead of asking, where are we making lots of changes, what we do is we say, well, what smells good? And this actually comes from, the idea comes from this book, Refactoring by Martin Fowler, the 2nd edition. It's really cool because instead of the examples being in Java, the examples are in JavaScript. he knows how to spell a book, right?
You know, if I could just, you ever heard Martin Fowler speak?
He was in a workshop with us and I like him a lot.
Yeah.
And he's actually amazing.
Yes.
But talk about an organized speaker and a really good writer. So, right. So you ask yourself questions like, when does a function get big? When does a function have too many arguments? When does a Boolean condition expression too complicated? Now, you'll read some of the Agile literature, and you'll get some of the refactoring literature, and they'll say, oh, you must change this, you must change that, you must change that. No. It's your judgment, right? It's up to you to decide. Don't refactor something just because the experts say you must follow their approach. That's the surest way to make a mess, because you're doing refactoring so you don't understand and you don't believe it. So refactoring is actually supposed to help the people who do refactoring, so that when they come back and they look at the code 6 months from now, they say, oh, yeah, boy, that really is clear. Right? And the hope is that that makes it clearer for everybody else.
Where does documentation sit? Refactoring.
Documentation is actually an important part of the refactoring process, because what you're trying to do is you're trying to make clean interfaces, right? And when you make clean interfaces, then you kind of write a little document that goes along with it. The clean code guides basically say you shouldn't have any documentation. The code should be self-documented. All right. One of the things I try to do in being ambitious is if I have lots of custom code and I see, oh, I have standard libraries. Some of this is for Jacob. It's in Python, since it's such a rich set of libraries. Java too, right? It's like, okay, using standard libraries can shrink the code size and increase the understanding, because somebody says, oh, I don't know how this thing works. Oh, but if that is done, right? So you can jump in and say, okay, can you take partial? But it's also interesting to refactor the. And that is one of my favorite books, Working Effectively with Legacy Code by Michael Feathers. And this book is Feathers is supposedly working on a sub-follow, it's 2000 long. And his examples were in C and C++. I think it was, but it's like, how do you actually look at a really horrible piece of code? And since if you don't have unit tests, you're dead, right? How do you basically break these up so you can add in unit tests, right? And it's like about 30 different strategies. So it's like totally practical. So this is one of my favorites. Yeah. Get that old code under unit test. All right. My second favorite book, and this is from about the same era. So object-oriented re-engineering pattern. Oscar Neerstrass is at University of Bern in Switzerland, and I think Dave Meyer and Ducasse were both students of his, but they're like, one of them's in France and the other one's at Antwerp. And they're brilliant. And they decided to make this book available as a PDF. Really nice. And they wrote it in terms of, right, here are some of the things. The best unit in here is called the first contact. What's first contact? That means you've landed on an alien planet, right? And this is the first time he's encountered this particular alien species, right? So there's all kinds of things you have to know as a protocol in order to make sure you don't get shot. Well, in this case, the first contact patterns say, what do you do when you're assigned to work on a piece of code, or you're said, they say, oh, download this thing from the internet and work with it, right? And they say, read the code in an hour. Say, can I learn code in an hour? Well, you can learn the file structure. You'll pick up some of the main variables. You'll see what some of the key functions are. You'll actually discover a lot of, where the build flags. All of that stuff. If you spent weeks, you'd be exhausted. But in an hour, you'd say, I have an appreciation for what's going on. He says, talk to the maintainers. They know where all the stuff is. Get to them, like, okay. They know which parts of the code are more troublesome, where they might factor. They have some idea and anticipating there's some content, right? But the other thing they talk about is set up some exploratory refactors. These are refactorings that you're going to throw away, right? But you're doing them so that you actually understand the mechanisms that the code is actually using for pulling things back and forth. So yeah, the code's the best documentation. But if you can use that to kind of create some probes into it to understand this is these are the key states of this particular class, this subsystem, or here's the key objects that get passed back in this interface. That can actually go a long way to reducing your discrete processes. All right, and we're just about done. So this is this is it, right? Talk about good practice. Legacy code isn't easy, but it's good we're learning about it. Learn some of these legacy software engineering techniques. Watch out for discovery costs. Add unit tests to your legacy code, and your goal is better quality and making it easier to be coached. And I say I brought along a few of my favorite books here, Refactoring Patterns. My old favorites too. I've loaded this stuff up into this project that I have. As a retired guy, I still work on stuff, and I'm kind of loading some of my resources onto the internet. So if you go to the refactoring project, I'm going to start including some more stuff about this legacy code stuff, including the little essay that you just got in the handout. But yeah, cool. This is I said the two books that I say these are keys, right? Is it if you sleep with the working effective legacy code under the pillow, you'll become smart. and this object-oriented reengineering patterns book is quite brilliant because they really do understand the kinds of forces that are going on in a project that's in chaos. You say, how am I going to start on some of this, right? So, yeah, refactoring techniques. So, questions?
It was interesting that